I'd like to talk a little bit about what an object is. I kind of can't believe I'm doing this because when I first started teaching this class 5 years ago, I had 5 volunteers and 2 people at home who kept trying to explain to me what an object was. But as they talked about objects, they used the word object to mean a whole bunch of different things. And at some point I was so frustrated I was on the verge of tears because nobody could get it, could be consistent about it. Um, and so when I started teaching this class more on my own, I decided that was it. I was going to split objects up a little bit, and instead of using the word object as broadly as it can be used, I was going to refer to 2 specific things about objects that will help you sort of separate stuff. So at some point you will probably talk about objects just like all of them do and conflate everything all back together again. But for right now, I'm going to split it up for your sanity and mine. So here you go. What is an object? So we've talked about this before. An object is a collection of data, right? And methods to act on that data. Okay, data and methods that act on it. So here are my 2 things. An instance of an object. That's like when we made a new Jabberwock and we made one like new Jabberwock that had like 9-inch claws and like super flaming eyes, and then we made another one that only had like 1-inch claws and it had no flames in its eyes. I think they named it Chicken. Anyway, each one of those Jabberwock objects that you created is a new instance of an object. So an instance of an object has a bunch of its own values. One has super long claws, one has super bright eyes, one has super short claws, one somewhere in the middle, okay? Each instance has its own values. And so when you go off to store those in memory, right, you have one instance of a Jabberwock object is like over here, and you have another instance of a Jabberwock object over here, and another one over here. You can have a whole bunch of instances of it, right? That is separate from the code that creates it. So an object's class, the object's class is the template for making instances of the object. So I'm going to split my talking about objects into an instance of an object, that's like the specific details and data that's stored out here, and the class that creates it, okay? So both of those can kind of be referred to as the object at different times, but I'm going to split those up for you, okay? So these are instances, right? Specific instances, named Jabby, named Chicken, named George, named Bob. I don't remember all the names you named them, but some of them were named Jay. And then an object's class is the template for making them. So if you think about the class and you go back to the Jabberwock code, you'll see that in the class, there are no particular values listed there often, right? Generally, and certainly to start with in my class. So you will see a list of variables, all declared, but none of them initialized. The initialization happens when you create an instance of an object and you fill in all of those pieces of data and give values to all of those, right? So not until you create a new instance does it get values. So the class, the template, just has the variable declarations, but no values ready to go in, right? It's very, very general. It's how you're going to build every single instance of this type, right? All right. What is in an object's class? So there are 3 things that I want you to expect inside of an object's class. I want you to expect fields. So those would be the variables listed generally at the top. There will be constructors that set the values of those variables, at least initialize them, and then the methods that come down below there that you use to work with those fields and the data that's stored in there. All right, so let's talk about these just a little bit more in depth, but I need you to expect that most of the objects that you see from here on out are going to come with fields, constructors, and methods. True in the AP test too. All right. So fields are class level variables. They exist for the entire class. So any method down below there will be able to see those variables, okay? They are usually private. On the AP test, they're pretty much always private. They do not have to be private, but there are really good reasons for usually making those fields private, and we will talk about those later in the chapter. Usually, they are not initialized before the object is created, or the instance of the object is created. See, I do it too. Usually, they're not initialized first. So, there are times where you might want to, but I guess you should think about it this way. You've got all of these spots out in memory, right? And you've initialized Jabby the Jabberwock to live right here. Okay, that's Jabby the Jabberwock. And then there's another Jabberwock whose name is George, and George is over here, right? You write code in the object's class with the understanding that it will call for I intensity when it needs it, and it will use whichever I intensity it finds, depending on which Jabberwock you are talking about. So you may not see in your code the actual values show up, right? Like the code that you write is super general. Whatever the I intensity is, I will do the following. So in your fields, when you set them up, they don't start with any values in them. You just know that every Jabberwock will have those particular values. And you decide whether they are private values or they can be seen from outside of the class. And you will initialize those whenever an instance is created. So when I make a new instance of an object, suddenly I'll have another spot in memory that's designated as a Jabberwock that has those three values. Okay? Constructors are responsible for initializing the fields, right? So when you want to create an instance of an object, you have to say the Jabberwock has this I intensity, the Jabberwock has claws this long, and the Jabberwock is alive, right? You tell it whether or not, you tell it information about those things, and it's the constructor's job to fill in those spots in memory and say, yep, I have made you Jabby the Jabberwock, or yep, I have whatever. When you see in the code the place where you've got a new Jabberwock equals new and whatever your class name is, that is you calling a constructor, and whatever you pass in as the parameters is going to be you setting the fields or giving it the values it needs to figure out how to set the fields. So the constructor's job is really to initialize the fields. It wants to set values for them to start with, so that all the code that you write from then on out, you use the fields for that particular instance of it. All right, methods. At the bottom of your class, you'll normally find a bunch of methods. These methods might be static methods, they might be instance methods. We talked about both of those kinds of methods last time in class. There are reasons why you would want static methods inside of a class that is mostly instance methods. We will get there. But for starters, we're really going to focus on mostly classes that have just instance methods to begin with. We'll work our way back. In Java, I'm cheating a little bit because the way Java works, every single class is an object. Every class that you've ever created up until now technically is an object. But there are objects that are entirely full of static methods, and so it's not really object-oriented programming in the sense that people mean it when they talk about object-oriented programming. So I'm going to talk a little bit next about what the heck object-oriented programming is. It'll be super high level and probably not terribly useful, except that maybe it'll give you some idea to attach some of these concepts to as we go through. All right? Give me a minute. All right. So when people talk about object-oriented programming, and please remember that I do not have a computer science degree, this is how I think about it. Your parents and friends who have degrees in it, please ask them. That's totally fine. This is how I think about it. So I think about what we've done so far as sort of a third-person thing. So if you were like some all-powerful deity up on high looking down on all of these creatures, you could see all these instances of objects or all of these variables, whatever it is, right? And if you want to know if this one is equal to this one, you say, hey, is this one equal to this one? I don't know, like, please tell me. And you plug them in, and you're looking down from on high. The way object-oriented programming works is that it's from the perspective of the object. You write the methods from the perspective of a particular object. So not necessarily, well, so you take one instance of this object, and this object knows what he can do, right? His template has defined for him certain fields, and the constructor set those fields. And the template, the class, gives a bunch of methods that can act on that data. So he can say, hey, am I equal to this other guy over here? Please tell me. Am I equal to it? Am I, like, what is my length if I'm a string, right? What is my length? But it's all, like, from the perspective of me, right? One particular instance thinks about, like, thinks about the world related to him, right? So if you made, like, a bicycle object, right? And you had your bicycle, that bicycle could say, how far away, like distance from school. What is my distance from school? Whereas in the kind of programming that we've been doing so far, it's very third person. You've got this bicycle, you've got school, and you take these two pieces of information, you plug them into the parameters, and you find the distance between them, right? From this, it's very first person, it's me. Think about, it's like teenagers' view of the world, right? It's all centered around me. Okay, maybe that's not you. Anyway, that's kind of the difference between the kind of programming we've been doing before and something that is more object-oriented. And you'll notice that this is more static methods, and these are instance methods. So we're going to go into Jabberwock again this time. And if you go to the link in the Canvas posting, you will see there's a Word doc that I want you to open. And you're going to fill in the pieces, partially what we did, and I changed the class a little bit and I added a couple things. So I'm going to go through it with you as a screencast. And we'll see if that works, and we'll see if it can sort of give you examples and clear some things up. All right, here we go.